Imagine running a busy shop. At the end of the day, you throw all your receipts, invoices, and transaction records into one giant cardboard box. Finding a specific receipt in that massive, unorganized pile is frustrating and wastes valuable time. To fix that chaos, a smart shopkeeper uses a filing cabinet. Inside the cabinet's drawers are labeled manila folders, keeping specific papers organized by category so they can be retrieved instantly. A computer hard drive functions exactly like a physical filing cabinet. Manila folders become digital folders, and papers become digital files. Zooming into a digital folder reveals an empty container. It holds no information until a file, like an essay, audio track, or image, is placed inside. Maintaining this logical hierarchy ensures your digital work is always where it belongs. When you consistently place files into labeled folders, you stop losing track of your documents and save the time you'd otherwise spend searching through a cluttered, unorganized drive. Building this hierarchy starts on your computer desktop. By right-clicking an empty space, selecting New, clicking Folder, and typing a name, you instantly create a new digital container. Many people assume that adding more folders slows down the computer or fills up the hard drive. In reality, creating a new empty folder consumes almost zero storage space until you actually put files inside it. Once your folders are ready, you need to transfer your files between different storage devices, like moving a document from your school computer to a portable flash disk. You have two primary command options for this: copy and cut. Look at the left side of this diagram. The copy function works like a digital photocopier. It duplicates the data into a new location, in this case, pasting a copy onto a flash disk, while safely preserving the original text file exactly where it was. Contrast that with the right side of the diagram. The cut function acts like a pair of scissors. It completely removes the original data from its starting location, leaving nothing behind as it moves the singular file entirely over to the new drive. Deliberately choosing the correct transfer method ensures your files end up exactly where you intend. It prevents accidental data duplication when you want to clear space, and stops you from accidentally leaving an original file behind on a public computer. This volume progression chart maps out how we measure the physical size of those files. It starts with a single drop of water, representing 1 byte. A byte is the most fundamental unit of computer data, representing the size of just a single typed character, like the letter A.
In standard math, a kilo means 1,000, but computers process data in binary, using on and off signals represented by ones and zeros. Because of this base 2 math, units escalate by multiples of 1024. Multiply our single byte by 1024 and we get a drinking cup, 1 kilobyte. Stepping up the ladder, we multiply that kilobyte by 1024 again to reach 1 megabyte, visualized here as a yellow jerry can. A megabyte holds about the amount of data in a high-quality photograph or a short audio clip. Multiply a megabyte by 1024 and you reach 1 gigabyte. This is the volume of a large rooftop water tank, which represents the capacity needed to store massive files like full-length movies. Finally, multiply that gigabyte by 1024 to reach 1 terabyte. This is the massive scale of a vast lake, and it represents the total storage capacity built into most modern computer hard drives. Calculating exact data capacity using this 1024 rule is required when managing your files. It allows you to accurately predict how much data you can move, preventing your portable storage devices from unexpectedly running out of space during a file transfer. Let's apply this measurement logic to a practical problem. A wedding photographer has just finished shooting 500 photos, with each individual photo taking up exactly 5 megabytes of space. The photographer wants to hand these photos over to the client on a standard CD-ROM, which holds a maximum capacity of 700 megabytes. Here is the layout of the problem. Pause the video right now. Calculate the total data size of all the photos combined, and deduce if they will successfully fit onto this CD-ROM. As you can see in this animated calculation, 500 photos multiplied by 5 megabytes equals a total data payload of 2,500 megabytes. Because 2,500 is larger than 700, the data cannot fit and bounces off the CD. The solution is a higher capacity portable medium. A 4 gigabyte flash disk holds over 4,000 megabytes.
allowing the 2500 megabyte payload to slot inside successfully. This cheat sheet visualizes the 3 pillars of file management. First, use the folder and file structural hierarchy to keep your workspace clean. Second, know the mechanical difference between cutting a file to move it and copying a file to duplicate it. And third, simply use the base 2 storage ladder to calculate your needs. Mastering these organizational structures and storage measurements allows you to manage your digital library with confidence. By keeping your files neat and knowing exactly how much space they require, you ensure your work is ready and transportable whenever you need it.